Let's talk about the basic idea of a limit and one-sided limits. So let's look at this graph on the left-hand side over here. When I look at this graph, what I'm going to do is I'm going to call this point right here 2. This point 2 is going to be, I'm going to call this A. And when I look at this graph, I ask myself, where does it look like this function is going as the x values get closer and closer to 2? So when I look at this, this looks like a line with a hole in it. To me, it looks like the function is going to whatever this y value is, which to me looks like it's 4. Okay, so I would say that it looks like this graph is going to 4. Let's take a look at the second graph. Again, my a is going to be 2 here, but this graph is different from the other graph. It looks like when I come from the left side, it looks like it's going to go to the y value of -1. But when I come from the right side, it looks like it's going to a different number. It looks like it's going to the y value of 1. Let's look at the third picture now. For the third picture, again, I have that point that I care about is 2. This time, when I come from the left side, it looks like my graph is shooting up to positive infinity. And when I come from the right side, it also looks like my graph is going to positive infinity. So these three pictures represent 3 different types of limits that we have. And what we want to do first is we want to understand the intuitive definition of a limit. The limit as x approaches a of f of x is equal to L. This means as x gets closer and closer to the point x equal to a, the function, the y values of the function appear to be going to L. If we look back at these pictures, I can write the following. For the first picture, I could say the limit as x approaches 2 of f of x is equal to 4, because it looks like the y values are going to 4. If I look at the second picture, I would say the limit as x approaches 2 of f of x, I would say this one does not exist. So I'm going to put DNE to mean does not exist. And the reason why I say it does not exist is it looks like it's going to -1 when you come from the left, but it looks like it's going to +1 when it comes from the right. So it doesn't look like it's going to just one single number. It looks like it's going to 2 different numbers. For the third case, I'm going to say that the limit as x approaches 2 of f of x, I think this one's going to positive infinity. Because when I come from the left, it looks like you're going to positive infinity. When I come from the right, it also looks like you're going to positive infinity. Let's take a look at another example, example 1, that will capture this idea even better. In this example, I want to use the graph to estimate the limit as x approaches -1 of our curve g of x. So in this particular case, I'm going to label the -1 over there. And let me label the y values. So the y values are 1, 2, 3, and 4 like this. And What do you think the limit as x approaches -1 of g of x is? There's generally two answers that students give. Some students say 3, and other students say 4. So which one do you think the limit is? Let me give you a second to think about it. The correct answer to this question is that the limit as x approaches -1 of g of x is equal to 3. And the key thing I want you to realize is for limits, we care about where the function looks like it's going. Okay? We don't care what the function actually is, what the y value at a actually is. So to make it perfectly clear, the limit as we approach -1 of g of x is equal to 3, even though g of -1 happens to be equal to 4. The limit is different from the actual function value. We only care where it looks like it's going. It looks like it's going to 3, but it happens to be equal to 4. Let's scroll down. I want to tell you about two important limits. So the first important limit is the limit as x approaches a of the linear function x. That's just equal to a. Okay. And the second important limit is the limit as x approaches a of a constant function. That's going to be equal to c, the value of the constant function itself. And what we're going to do in the future is we're going to use these two important limits to calculate other limits. So I want to mention that to you first. Now, we have a special notation for something called one-sided limits. One-sided limits means, you're taking the limit as you come from the left, or you're taking the limit as you come from the right. So let's write down the notation for these two types of limits. The limit as x approaches a, if I want to indicate I'm coming from the left, I'm going to put a little negative sign in a superscript there. That'll be f of x. Okay, so that's a one-sided limit from the left. If I'm coming from the right, we're going to write that as the limit as x approaches a from the positive side of f of x, like that. And the reason why we call it this way is, you know how the negative numbers are on the left. So if you're coming from the left, it's like you're coming from the negative side. On the other hand, if you're coming from the right, you're coming from the positive side because the positive numbers are on the right side of the x-axis. So coming from the right gives you a positive thing like that. All right. So as an example, for this particular graph that we have here, the limit as x approaches 2 from the negative side of f of x, g of x, that is going to equal to -1. But the limit as x approaches 2 from the positive side of g of x, that's equal to +1. And I hope that's obvious from the graph. You come from the left, oh, you're going to -1. You come from the right, oh, you're going to +1. Okay. All right, everyone. We'll look at more specific examples when we meet together in class. Take care.